On the workbench here is a standard North American 20 amp female plug that's been part of an extension cord. It was removed from service. I then cut it up with a hacksaw to take a look at the inside. In this video, I'm gonna share this with you. It's been removed from service with the extension cord because of the charring that's shown around the neutral blade, or a little bit around the hot blade, and there's also some discoloration around the ground pin. Out of an abundance of caution, obviously this charring and discoloration raises some eyebrows and is a concern, so it's been removed from service. So let's take a look at the damage, the actual damage on the inside. I obviously disconnected all the wires from it, so this will just separate simply like so. And there and there. All right. So this 20 amp plug was designed to work both with a 15 amp plug as well as a 20 amp one, so both of them will plug into it. You can see the neutral blade here works either for a vertical orientation or on a 20 amp male plug it works with a horizontal orientation. So in North American wiring standards, this here is the ground pin. This is where the live wire or the hot wire, the black colored wire, should be connected, and this is where the white wire is connected. On this one, it just so happens that the white wire was connected to this side instead of the black one, and the black wire was connected to this side just for a starter. So incompetent assembly is part of the equation here. Let's take a look at the heat damage that's been incurred here. Obviously there's been arcing and sparking inside, a loose connection for whatever reason, extension cords get thrown into puddles, whatever. So let's see how bad it is. And I want to focus on the ground pin first. At the edges there's a little bit of this discoloration, but I think most of it can be explained by normal regular use, either 15 amp, whatever, it doesn't matter, the same ground pin. So this is just from plugging things in like so, and I think it's not rocket science to understand that the ground pin is rubbing the plastic housing right there, so that's why it's been polished or shiny. So the discoloration there, the blackening, is from some of the metal being transferred to the surface of the plastic. So far so good. So this black discoloration here is perfectly fine in normal operation. Let's take a look at the extent of the heat damage. That's how this looks like. I can see that nothing is molten yet by a very thin margin. So the melting is worst here and here on both sides. And maybe at the time of the damage, the plug was oriented vertically, and the heat would, let me grab this pen here, the heat would then rise in this space here, whatever, and cause the most amount of damage. Obviously is here and here, where the yellow plastic blackened, and the second worst spot is somewhere here. So heat was somehow rising, and the third spot is there, somehow rising in this space. So what's in that space? What's in that space are these copper spring plates. This is how, there we go, there. So that would be the hot blade, and this would be the neutral blade, and it plugs in like so. So if I remove the yellow plastic from this again, plugging in with the spring blades, looks like this. Now obviously the male plug is intact, and the female plug has been subject to is band sewing, and that's a mark from my vise, as it was clamped into a vise for cutting through with a hacksaw. But the spring copper plates that grip the blades on the male plug, the copper itself is intact. It's just as springy as it should be, either this one or this one, and it's holding the male plug blades really firmly in place. So where did the arcing and sparking come from when these two don't seem to be loose visibly in any way? Well, I guess we'll never know, but because of this friction fit nature of plugging things together, the spring plates wear a little bit, but the male blades also wear from their thickness a little bit. And if the male plug at the end of whatever is being plugged into it on the power tool on this extension cord, so if the blades are too thin, there could be some arcing and sparking here at this neutral cluster of spring plates here. So there's no further evidence of heat damage inside this, just by looking at it this way, but there very well could be. Just out of curiosity, I'm gonna try to remove this spring plate assembly here. Alright, so this is the neutral blade taken out. Let's see some evidence of heat damage, if any. Obviously it's not dimensionally deformed because it's not made out of plastic. But heat affected it and discolored it towards the tips here. So that's all that happened to the metal part. I'm trying to see inside the plastic housing where the neutral blade spring plates are housed, and just to see if I can spot anything that looks like heat damage and not mechanical, that's gouging that I caused by the screwdriver tip, but no observable deformation due to heat. So that's, and this was the worst affected side. So yeah, so the metal blades are unaffected by the heat, which was generated down here. That's where the looseness was, because that's where this is the blackest and or the most charred. So that's how this one, the metal part and the plastic housing kind of come together. So this is where the metal was the hottest. The metal is intact, but the plastic is dimensionally deformed. Was this a good call to remove the extension cord from service? Yeah, it was a good idea. Once it's charred and burned, the plastic itself will dimensionally deform. It's not going to be the same as before. Will make plugging in even more difficult, whatever. So if you see something that's this bad, just take it off of service, cut it up, or just make it inoperable so that nobody else uses it by mistake.